and welcome, or welcome back to episode 5 of Whether or Not. I am Stella Q, very happy to have you here to join us for another day in Geek's Paradise, where we take a big old geek peek under the bonnet of the big sky and all the doings that dwell within that vast expanse of whole lot of nothing. That is chock-a-block full of so many wonderful things. And some other stuff. Oh, TM. It's another day. It's time again to don our meteorological forensicist hats and polish our looking glass as we squint skywards and set the truth free to fly, free to fly. This episode is our first Q&A, and first of many, I predict, because there's a whole lot of questions floating around the ether out there, and we plan to try to tackle at least a few of them, one bit at a time. And it's a fairly safe bet that the stormy questions won't ever run dry, so looks like we're here to stay. At least until the next global cataclysm, for which I have my deck chair and sippy cup all set up, ready to rock and roll into oblivion. But in the meantime, let's tackle what's right in front of us, or above us. Because we know a guy, right? Our friend Jeff. His head is always in the clouds. It's his happy place. And he's a bit of a wise guy, see? So here we go. Let's take on board our first Q&A and safely locate and land the plain truth as we dive deep into the big question. Was it weather or not? G'day Jeff, how are you doing?
Hey Stella, I'm great, thank you. How are you?
Very good, thanks. And today we have something a little bit different. It's a whether or not question and answer session. And in this world of acronyms, that spells Wonka. So, shall we go with that? We've had a number of questions come forth since we started this series, and we're going to start with one about one of the one of the subjects that's very dear to our hearts, cloud seeding. So this is one from one of our lovely members from the Climate Viewer Telegram chat. Jeffrey M. Are you able to detect cloud seeding in my region, which is Gibsons, British Columbia, from the last 2 nights? We literally had rain in the middle of the night of August the 10th, out of the blue sky to rain. Very, very unusual to have rain here in August at all. So last winter was an El Nino, and so this summer supposedly would be followed by an El Nino? Question mark, question mark? How would you respond, Mr. Jeff?
Oh, okay, we're going to look at all the charts. I'm going to actually show you how to go about doing this. The 4-step process that it kind of takes. It's really very simple. And we're going to actually look at the weather in both British Columbia, where this person was. And there's another question too, right, Stella, that's going to be coming up that I prepared for as well. And that's in Australia. So
Correct.
I just need to show you all the charts and all the things that I do to accomplish this. It starts out with a video, 4 short video clips.
Alrighty.
On an actual cloud seeder.
Sounds great. Let's take off.
Okay, so that's a what they call a King Air. I forget the model number, but it's a King Air 90, I think, probably. It's a pretty fast and capable aircraft, and here we show some cloud seeders with all the gear that they have to fly. Flares on the wings and fuselage inject silver iodide. And the important thing about this is that you can't make a storm happen, and you can't create the conditions. That has to happen naturally.
Right, so there's no magic involved. It's all piggybacking.
You're waiting for the conditions to arrive. So that's the first important point. These are the flares on the back of the wings. Those are the ones for above cloud wing flares. They shoot downward, and they use these other flares on the back of the wing while they're in cloud. They burn for 4 to 5 minutes, and it trails the smoke. That's the second important point. Third is this. Supercooled air is what you require. So you form snowflakes when the water is supercooled. And as they freeze, they start to accumulate water on them. So this is an ascent thing. They're cooling the air. They're dropping into the cloud. Air is usually going over a mountain. As it ascends, it cools, and that causes condensation. So that would have been something in our cloud video that we did on part 2 of the cloud video. So at this point, they're saying here, as the air ascends, it might be 50% ice or more than that. There's still a lot of water that's left, and it has a very short time to get big enough to fall out before it descends and then it warms. So that's a really important thing. It's got to be on the cooling aspect, on the cooling side, which is the rising side of after they inject it into the sky. And the fourth thing is this just shows the flares, and if they're in cloud, they use these. They light one at a time, and it just smokes out to the rear into the cloud, and it provides the condensation nuclei. It also has other things in it that probably aren't so good. And they used to actually have spec sheets on these that they removed from the website shortly after I found it back in December or so. So
of course they did.
Those were the videos that I just wanted to make those several points off the start before we actually get into everything else here that I want to cover.
Can I ask, you may not know this, but how do they light the flares one at a time? Is there a switch or something that the pilot does, or
I don't know. I don't know that,
Okay.
Stella. I'm sorry. I don't think they have to crawl out on the wing, though.
Yeah, okay. Really long match. All right.
So here's the situation up in Canada, off of British Columbia, near Vancouver. The place that we're looking at is called Gibsons Landing, and that's right there in Puget Sound. So I can zoom that in a little bit and show you exactly where that is. This is where the questioner was from. So there was a small amount of rain. This was last Sunday morning, early AM. The time was up here, the 8th month on the 11th at 0900 UTC, which happens to be 0200 Pacific time. If I actually go to, that's radar right now, so that's actual. Precipitation will show a larger area. They usually show more than there actually is on this Ventusky app, Ventusky. When you click the radar, it's the actual. So there's a very small shower, and if I go ahead and click through that, it passes right over Gibsons Landing. There are a couple other showers in the area that are farther to the north, up at the north end of the bay. But for the most part, that was it. It passed through.
Okay, now we're looking at the 11th at the moment, are we?
Yes.
Because I believe the question was something prior. Let me just put it up again there. Let me just double check that. We literally had rain in the middle of the night on August the 10th. Right, okay. Yep, cool. So
morning of the 11th. So literally, it was 2 a.m. when it first started. And for some reason, this thing is locked up right now. But that was just a very brief shower. But you could see over the higher terrain up and towards the mountains of the Cascades right here. This is the northern part of the Cascades. There was more rain.
Looks like fairly light rain from the gauge, though. It's,
It was very light. Yeah, it was like a couple of millimeters. So what the situation is in the atmosphere, there's a low pressure center right over that at that time. So I have this looping here. It's a fairly long loop of from 0800 GMT Zulu UTC to 2300, which is into the afternoon. So you could see what's happening here is that low is tracking right across Vancouver Island. And in the afternoon, you see the convection adding in. So off the start, during the midnight hours when this is, as that low is coming in, it's just, you could see this, the showers developing right here, right over Vancouver. So that's just from lifting. Here's another view, which shows slightly better.
What's causing the lifting?
It's just due to lifting. Yes.
Right.
Strictly due to lifting. So if you remember, there were from the cloud video, you have 4 things that will cause lift, which would be orographic lift. That's what the case is here, which is topography. Convection, which is your afternoon heating. Convergence, which is when you have a whole bunch of streams of air going into the same spot from different directions. That's what you have happening with that low right here. And the 4th, frontal lift. So this is like the same as a front too, because this is like a mini cold front right here. That's a low pressure center where all the air is converging. So I looked for flights, and to determine that, first of all, it's a 4-step process. You have to determine the altitude that they need to be at, and you're looking for a temperature of -5 to -10 degrees Celsius. And where we look for that is an app called Ventusky. And at 14,000 feet, you got this temperature tab up here. And if you go into, you have all these flight levels or height levels that correspond with a altitude. For instance, 850 millibars, hectopascals equals millibars, which is about 5,000 feet. 700 is about 10,000 feet. You could see at 700 millibars at 10,000 feet, which is 3,000 meters, it's 5 degrees Celsius. So you have to go higher to get colder. At 12,000, it's 0 degrees. So your freezing level is 12,000 feet, about 3,500 meters. Up at 500 millibars, it's about 18,000 feet, -12. So somewhere between 14 and 18,000 feet is the level where it hits -5. So I'm going to say 15 to 16,000. That's where I'm going to look.
Okay, so that's the cloud. That's the cloud seeding sweet spot.
Correct.
Right.
And then I go into Ventusky, and I'm not sure if this is available for somebody that doesn't have a subscription.
Flight Radar. 24.
Yeah, Flight Radar 24. Thank you. I have a gold membership, so I can go back and I have history. I can go back for 1 solid year, I believe it is. So right off the start, I'm starting this before at 0714 UTC, which is a couple hours before, to see if I can find a seeder prior to, they'll be out before the rain's going to arrive. They're waiting for those natural conditions to happen.
Okay. Can we just stop there for a sec? That's a good question. Yep. How much time before a storm comes do they have to do this seeding? Does that vary?
You want it to be the right time. That's really simple to say, but the moisture's got to be there. They don't want to go up and fly around in circles waiting for it to come. They're going to time it.
Yeah, because I mean, time is money as well, isn't it? So
it's burning fuel. I mean, I got to show you something right off the start. So this is a billing statement for 1 month of seeding. So they have to do, it should need to be cost effective, but I'm going to show you an invoice. I'm not going to show you for where or what company.
And this
but
is not made out to you, is it?
This is not to me. This is
Okay.
a month's worth of seeding operations. November of 22. So it's probably higher now.
Mhm.
You have a base rate of 30 days, $15.77 a day.
And
They
33
charge
cents.
fuel and 33 cents. The flight time at $700 per hour. This was 4 flights. And then the ejectable and the burn-in-place flares, all cost. And there's a mobilization and demobilization fee for the aircraft that's there. This is a month, but that 14,000 is one time in, one time out. So you wouldn't pay for the other months that you're waiting there. But that's $81,000.
That's a steal.
I think they can kind of make money on that, probably.
Mm-hmm. Who do you think the clients would be? Is that too much speculation?
Ski hills, water districts, for reservoirs, like in California. We need the water out here, so they're trying to wring every bit out they can.
Right, okay.
So, multiple clients, probably even to farmers at some point somewhere, I would think. So when I go right here.
Can we zoom in on that, please?
We can. I think, let's see, command. Okay, and I'll scroll up a little bit. So you can pick, I call this 12 to 20,000 foot filter, and you can pick down to airlines, aircraft type, airports, routes. Categories is the one that breaks down. I have the types of aircraft that I'm looking for: drones, military, government, general aviation. And then you have advanced filters. So I'm filtering it for speeds of when those guys would be, what speeds they would be going for. That rules out every fast mover, a jet that's passing through the zone. If it's, accelerating at 300 knots.
Right.
And then you're not going to see that jet on the filter. And I'm looking for a really wide range. This is 15,000. So I'm going a few thousand feet above and a few thousand feet below to catch that guy going to where, as he's going there, so I don't miss him. So that's my filters. I want to get back, command 0, get back to that, and I'm going to show you. I'm actually going to play this, but I won't do a lot, but you can see what happens here.
Can you just explain to us all those little blue tags that we're looking at there?
Okay, those are the airports. Those are the airports,
okay.
and you can, I'll zoom in a little bit to where you can focus on like one aircraft. This is showing the flight level, the speed, the flight name, and where they're going. So this one right here, if I just look at that, I'm saying that's at 2,400 feet. You add 2 zeros, FL024 means 2,400 feet. This one up here would be 8,000 feet. This would be 25,300 up here on the top. That's the flight level. FL253 is flight level 25,300. And it's going 440 knots. And that's the name is ROU 1903. That's this call sign. And it's going from somewhere in Canada to somewhere in Canada. I don't know the identifiers YYZ to YYJ, but those are the actual destination and takeoff points. So each of these has just a small icon on it that tells you where they are, so you can see from a distance.
Okay, so each of those airports has a little like YYC,
yes,
YYJ. They've all got their own little registration, I suppose that is.
Yeah, aircraft or airport call sign, like that's Bellingham, like that's right there, Orcas Island, East Sound, Orcas Island. Up here you have Seychelles, and there's Gibsons, which is where this person that asked the question is located. So I'm going to play this right now, and you can see the motion of these guys. This is 0715 time, 01456 UTC.
Yep.
So watch these guys start moving. And this is early in the morning, so it's light already. And as soon as I flick filters on, everything disappears. Now we're looking for two types of aircraft. I have King Air because I know that they're really good for this. If I see any King aircraft, I look at it. And I'm also looking at,
because their aircraft is ideal for cloud seeding, correct?
it seems to be. They use it a lot in the places that I've watched this happen, and they get around the world. I mean, the one that you saw in that video right there, it's in Seoul, Korea right now. So they're capable of going anywhere.
Mm-hmm. Right.
So right now, that time is clicking up, and I can click that speed up to 300 times. So I can watch very quickly. So now that clicker's going up fast. And I've got so many tabs open today. I'm hoping this doesn't crash on me, but right now that's clicking fast, and you can see there's no aircraft in sight. So I looked through this entire thing. I didn't find a single aircraft that was seeding. We'll watch this for just another minute just to show you. Maybe we'll get lucky to see one here. But if we did see one, and I could show you something. I'm going to take the filter off again for a second. I want to show you the features of this.
Okay.
So let's say I'm going to pause it because they're moving around fast. This guy
that
right
also
here.
shows us that there is aircraft in there. It's just that not at that specific height that you've got your filters set at.
Height and speed. I remember I had that speed of about 90 to near 200. So this gives you the ability, you can click on any aircraft, and it's going to give you a lot of information for them on the side. So this one is going from Seoul to Atlanta. This is a jet, big jet.
Passenger
jet. And
that's
Korean Air. And it's showing departure and arrival times and the type of aircraft. And it's at 35,000 feet, and its vertical speed, it's flat. It's just cruising speed, cruising altitude, cruising mode, 0 feet per minute up and down, 541 knots. So here's a really cool thing. If I found an aircraft, I can look at the altitude and speed graph and drag that off to the side so it's not in my way, but it's not really in the way because I'm focused on this area, but there are no aircraft other than this, just to show you. So the blue line is the barometric altitude, and you can see it steps from 31,000. It stepped up at 35,000. That was the time. There's a time on there that it happens at 6:51 UTC. It was at 600 knots and 31,000 feet, and then it got up down to 500 knots and 35,000 feet, and it changed again. So it's constantly varying at speed. That's the yellow line, and its blue line. I could go and actually look for a cloud seeder just to demonstrate what it looks like on a seeding operation that I can't find one here. So rather than, we're not going to sit through that and look deeply into that, but
right. So it's sort of like when you're on you're doing a long trip and then you hit the freeway and then you're in cruise speed. So that's basically what planes do.
They got up to 37,000 feet and they hit 600 knots at a point, and there's altitudes on the left and there's your speeds on the right.
Yep. And time along the bottom, is it?
And the time, yep. They're moving so darn fast. Well, it shows where all of them are at that moment in time.
Oh, bang. They look like they crashed.
That's kind of the point to that. You have the speed and altitude graphs along with their identifying information. And if I went back to the mode of back into filter mode, as the time's clicking up, I could find one here really quickly. If I zoom that thing along, I could probably
find. It's a lot of information, isn't it? I'm quite surprised that they
It's
I mean, they even tell you how
incredible.
old the plane is and all that sort of thing.
Exactly. So I actually had one right there for a second. Before I go on, I'm going to find that one. I got to drop the
Yeah.
speed down from 300. So it was right there. And I want to click on that low flying aircraft. They show different icons for different types. And where did you go?
We saw you.
I saw it sneaking over there. There he goes. Okay,
hiding
so
behind a cloud.
there's a small aircraft,
Mhm.
and it's gone again. So it
That's a
went
bit
through the
strange.
area of the filter. So
Oh, okay. So it's it's
it
probably its
exceeded
speed
either
or
down.
altitude might have. Yeah.
Right. We do have cloud seeders later in the presentation, so I'm going to get past this right now. So we determined that we wanted 15,000 feet. I've watched that entire loop for several hours around when that rain happened, and I found no seeders. But what's the reason for all that? Why was there rain up there? We saw that low pressure center right there that
Mhm.
provided the lift, and that's another view of it, that another satellite view. And then you would, if you're the aircraft commander, they have to look at this. So they would be looking live versus what I'm doing here. I'm looking at history. I'm looking from a 2-day period to look at the conditions of that atmosphere, just to show you guys that it was not a cloud seeder that made that shower.
Right. So we're
And
looking between the 10th of August and the 12th of August, correct?
correct, at
All right.
00 Zulu, which is the same as UTC, which is the same as GMT, Greenwich Mean Time, which is
Yep.
London.
Zulu
So
being the military version of UTC, is that correct?
correct.
All right.
So
Affirmative.
here we go. This is Port Hardy, which I'll show you on the Windy app. Port Hardy is this location right at the north west end of the island. Vancouver's right underneath my hand right here. So Port Hardy is where that radiosonde was. So I'm looking for a 2-day period, so I'm using this app right here, which is University of Wyoming. And you're able to pick any continent, just to show you that. And you're able to pick what type of data you want. So I can get numerical data. I can get GIFs and PDFs of all this stuff. But what I'm looking for right now is just a pictorial view of what the atmosphere looks like. And for anybody that's seen clouds, I broke into radiosondes a little bit, and I'm not going to get too deep into it right now, but what's important here is I'm looking for these two lines. This is the temperature of the air as that radiosonde goes up in the atmosphere. This left line is the amount of moisture in the air. It's called dew point. Off to the left, you have the millibar level or hectopascal level, and it goes from 1,000 up to 100 millibars, and that's about 100,000 feet up there where that balloon pops. It's going to be north or above 100,000 feet when it pops. But as it's ascending, you're getting this temperature line and this dew point line, and when these two lines are real close together, that's telling you have clouds. When they're far apart, like here, you have dry air. Like up here, very dry air. Right here, you hit the tropopause, which is the top of the troposphere, which is where all the weather is. And then you're in the stratosphere where the ozone is. And it widens up there a lot. So these temperatures are, this is the minus 40 line, this purple one, minus 30, minus 20, minus 10, 0. So up there, it's minus 30 right here. This is the minus 40 line. It doesn't get quite to minus 40. It's about minus 36, the
And we're
coldest
talking
temperature.
Celsius. Celsius, is that correct?
Correct.
Yep.
So I know for a fact, just right here, and this is below 3,000 meters. 700 is around 10,000 feet, 3,000 meters. I know I have moisture at this time. This is the actual time of that rain that was happening. And because I specified a range, I can go back and look a couple days earlier and a couple days later and see how that changes in time every 12 hours. So the earliest one is right here. And then as you're coming up to the time when that was happening, you have moisture down low, moisture up high, clouds up here. And you go in the next one, which is the time where the rain was happening. You had moisture down low up to about 800 millibars, which is about 2,000 meters. So up to around 6,000 feet. And then
So
you had
that
a
would
gap
be.
of dry.
Mhm.
What's that, Stella?
That would
Sorry.
be considered. Sorry, that would be considered low cloud.
That would be considered low clouds down here,
Okay.
yes. And
Right.
in this range up here, 700 millibars, 10,000 feet, up to maybe 500. That's like the bottom where you get the cirriform clouds. When it hits minus 20 degrees, you get into cirrus. So in the mid clouds, you can see right here, there's mid clouds up there as well. This is at the time of that rain. And then I go into the next period, which would be drying conditions all the way up. And then you have this is back to the beginning. So I have a 2-day period for radiosonde releases through here.
Mhm.
And in no case do you see much more than 5,000 or 6,000 feet deep of clouds. So that's why you can't get a strong rain shower, because the cloud depth is not high enough. You have to get like a cumulonimbus. You need to be getting tops up to 300 millibars, 10,000 meters in the summertime. You can't get a strong rain shower, which you didn't have, because the conditions are not there. That gave me what we just looked at, shows the vertical profile of the atmosphere.
Mm-hmm.
And there's another way to look at it using the Windy app. And I have that here. I clicked on Port Hardy again, and I have like Quileute, Washington. There's Edmonton's way up here. There's all over the place. You have all these locations, which are the yellow dots, that I can get the atmospheric conditions. So there's a history right here, a history feature that you can go back. All these times are the release times for that radiosonde, and I picked the one.
Okay, so that's
when that
the
rain shower happened.
That's when the weather balloons are all released at the same time around the world.
Correct.
Okay.
So in this case, if I was a cloud seeder, I want -5 to -10. So that's starting right here. And let me get that out of the way. Right here at 4,570 meters, 583 hectopascals, I hit -5. And -10 is the low range, the coldest temperature where you would want to be, where I've observed them too. I've seen the spec sheets, and -5 to -10 is the answer.
Mm-hmm.
There's a 5-degree spread right there between that temperature and dew point. When you have less than 5, you're forming clouds. So this is a cloudy zone up here. He would be in clouds, and if he were to drop anything, drop or eject silver iodide, it would be in cloud. They might get some formation of droplets, but then it drops through a really thick zone that's really dry, from 3,400 meters all the way down to 2,173 meters. So that's a 3,000 or 4,000 foot thick area of dry clouds where it might evaporate. It's really not cost effective. They would have been looking at this prior to even going.
So can I just ask?
Yeah.
If let's just pretend that he did actually do some silver. Well, somebody dropped some silver iodide up in the area where the sweet spot, and
right.
then it goes down through the dry area. What happens? Like, does that just mean it gets blown away somewhere else, or what happens to the silver iodide if that was dropped in those conditions?
It evaporates again.
Because the powder?
That's a really dry zone. Not the silver iodide itself, but your rain. The point is to get rain out of it.
Okay, so what happens to the silver iodide though? Like in that situation?
It's going to go down into the ground. I mean, wherever
it just drops.
Yeah. Right. I mean, as that rain evaporates, as it's going through that, there's a temperature spread of 30 degrees right there. That's
So I mean,
super.
they just wouldn't. They just wouldn't.
They wouldn't do it.
Yeah.
It wouldn't be cost effective unless they're doing it just to get paid for one of those flights. But that invoice showed 4 flights. If it would have been 5 flights, there's another charge. I can't say that. I mean, there could be ethics involved here. So
check your invoices, people.
Yeah. So the other thing too is I just want to show you that into the afternoon hours, when I look at Prince George sounding, and I'm not going to get into how this works, but in the afternoon hours, which was that time of the rain was, what did I say, 0900 on the 11th. So I'm going to look at the 12th at 0000 or 0 Zulu, 0 UTC. And I'm going to show you that the air completely changes to where this becomes unstable. So the 12th as 0Z. So right now, there's some things that are called lifting condensation level. That's the height that you have to lift the air to get condensation. And there's a convective condensation level, which means heating related. So they're both almost identical, 2,700 meters. Mm-hmm. So this app allows me to figure out the temperature that it takes to get unstable conditions, 28 degrees. It hit that. You could see the red line right there. You have showers happening in that air mass in the afternoon heating. So you would expect to see on the satellite, which I have right here, you're going to start seeing all these white cells, because I brought this up to 2300 Zulu, which is late afternoon. You could see that air mass is really unstable, but it requires heating to get it there. You have a low doing the lift. You have convergence happening there. This is all weather related. That rain's happening completely just because of that low pressure center with the lift that it provides in the early morning hours and in the afternoon hours. I actually changed the size of that, so that's why it's reloading right there, and to make it a larger area that you'll be able to see this once it comes back up. But you didn't need to have cloud seeders there. The rain was coming no matter what, and it's off-season rain, so it's pretty abnormal. It was really weak rain, and it was due to that low pressure center and the lift associated with that, followed by the afternoon heating. And here you can see that afternoon heating. That measures the cloud top temperatures that we're seeing here. The bluer you get, the higher the clouds are. So they're starting low near ground level over the mountains, and through convection, they're rising up to much higher heights in the afternoon hours. And if I go back to windy again,
it's like just the sun heating the day.
Yes.
Yep.
If I go back to Ventusky with the actual radar and I go to 5 p.m., you can see how this changes. It's going to be showers everywhere up there. On the actual afternoon heating compared to that 2 a.m., tiny little showers near the bay.
All right, so and not a cloud seeder in sight.
Not a cloud seeder in sight.
All right.
So that kind of covers place location 1.
Okay.
I think.
Well, that hopefully answers the question.
Yeah, I don't know that I need to get in. I didn't get into the numerical data. That's okay, but just really quickly, Port Hardy, you can get not only that graph, but you can get it numerically, and that shows the relative humidity at each height. There's your pressure level, height, temperature, dew point, relative humidity, and this is called a mixing ratio. That's how many grams per kilogram of dry air. And you can see as you rise, it lowers as you go higher and higher into the atmosphere. And when you get up to 7,000 meters, it's less than 1 gram per kilogram of dry air. And when you get up even higher than that, like 10,000 meters, 0.07 is your value of moisture up there. And
Okay,
as you
so
get
can I just
higher,
ask,
yes,
these numbers, they correlate with the pressure. Is that correct? It's sort of like
the
the weight
pressures
of
are on
the
the
air?
left. There's your pressures, yep.
That's the pressure. Okay.
And the
Right.
height with that pressure. And the temperature, 7.4, 3.3 is the dew point,
Dew point. Yep.
and 75% humidity. And if you took the difference between the 7.4 and the 3.3 right here, that's your dew point depression. And when it's under 5, you have clouds nearby.
Right.
Not
Okay.
necessarily in cloud, but they're forming when you have less than 5 degrees.
So would it be accurate to say that this is the numerical version of the radiosonde chart?
Yes, exactly.
Okay, gotcha.
That's the numerical depiction of this. And you can quickly see where the cloud area is by looking at this. When they're really close together, you can, as you get good at it, you can see that relative humidities are high here and they're lower. I think the graphical version is easier for most people, though.
Yeah, okay.
I know for a fact now that I've covered everything on that British Columbia situation.
Okay, that sounds good. Well, I hope that answered our friend's question. Well, there you have it. Looks like the wild weather needs no help from us measly little humanoids. It can wreak havoc all by itself. Well, at least that's the case this time. But our eyes are on the skies and we are watching you watching us, TM. One false move and we'll be zapping you with our
intergalactic laser truth gun.
So be warned. We had another question from my neck of the woods this time. The land down under, as it's known for some reason. Under what, I ask? And is Australia even real? That mystical land where mammalian-looking things lay eggs and Big Bird wants to kill you? And let's not even bring the drop bear situation into focus. They're probably listening. This and so much more coming up in our next episode of Whether or Not Q&A or Wonka version 2. So I hope you'll be joining us for that, and thanks for lending us your brains. Cheerio, and take care, everyone.